So this mathematical induction says that we should prove that this formula is true for all the values of n from 1 upward. That is, if you check 1, 1 must be equal to 1 into 1 plus 1 over 2. If you move to the next step, 1 plus 2 must be equal to 2 into 2 plus 1 over 2, following the right hand side now. If you move to the next one, 1 plus 2 plus 3 must also be equal to 3 into 3 plus 1 over 2. Let's check if these things are true. Now, if you check this, it is true. If you also check for this, it is true. If you check for the next one as well, it is true. Now, for how long are we going to do this to make our conclusion? That is where the use of mathematical induction is necessary. So if you are to apply mathematical induction, you don't have to go through all this stress. All you need to do is follow these 3 steps. Step number 1, we'll call it the base case. The base case is the situation where n is equal to 1. I'm talking about this base case. You check it. Is it true? When n is equal to 1, as the first or the least number here, then the value of n is 1 plus 1 over 2. And at the end, we have 2 over 2, which is 1. Then you conclude that the base case is true. Now, for the second step, which I'm going to call the inductive step. Here, what do? We are going to assume that the formula is true. For n equals k, assume the formula is true for n equals k. That is our hypothesis. So what does that imply? It means that 1 plus 2 plus 3 plus k equals k into k plus 1 over 2. That is according to the formula. You assume that this is true. The next step now is the step 3, which I call the inductive proof. Now, what do we do here? You set n to be equals to k plus 1. And here, you prove that it is true. How do you prove that? According to the formula, if n equals k plus 1, then we have 1 plus 2 plus 3 plus k plus 1, which is going to be equals to, now don't forget that n is k plus 1. So this into k plus 1 over 2. So in this case, let's simplify the right hand side. So we have 1 plus 2 plus 3 plus k plus 1 equals k plus 1 into brackets k plus 2 over 2. Now let's go back to this aspect. We can deduce that everything here is equal to everything on the right hand side. So we can bring that in by replacing everything here with this. And that is going to be k into k plus 1 over 2, then plus k plus 1. So if the simplification of the left hand side is able to give us what we have on the right hand side, then we can conclude that it is true for all the values of n from 1 upward. So let's do that. We have k into k plus 1 plus 2 into k plus 1. So if we are to simplify or factorize, we see that k plus 1 is common to these two parts, meaning that we can have k plus 1 into k plus 2 over 2. Now let's compare this to the right hand side. Look at the right hand side here. They are the same. They are the same. So from here, we can conclude that since the base case and the inductive steps are true, then the formula is true for all n is greater than or equals 1. And this has been proved.